Hello, young people. It's Miss Rains again. I am trying to help you with ionic bonding again and trying to see if we can get a better idea of how we kind of reverse engineer a problem. So we've always started from the ions or the substances and gone to the formula and the name. What if we have the name or the formula and we have to decode what's happening? So let's look at that. So we're reverse engineering with ionic bonding. So we're writing correct formulas from names or writing correct names from formulas if we need to. Determining ions needed to make the bond by bond given by the name. Using a method to find the correct formula. So visual plus and minus method. You notice I got rid of the dot structure method because it no longer functions unless I'm in binary world. Unless I have binary compounds, this does not function. Or the dot method does not function as well. Not without a little bit more stuff. So let's say that we have the substance Fe, works with every possible combination, I'm sorry. So we know that already. We've already looked at that. So what if we have FeNO3, 3? We need to know the name of this substance. Well, we happen to know that Fe is one of those things that is in the D block, and it can change charge. So we have to be thinking about how do we reverse engineer this process? Well, we can do that by knowing how many of each thing that we have. So we know that we have one Fe. We don't know what the charge is on it because it's Fe. We have multiple charges. We also know that we have NO3. But the thing about that, we know that we have 3 of them. So we have 3 NO3s. And if we look on our polyatomic ion sheet, we'll also realize that each of those NO3s has a minus 1 charge total, for a total of 3 electrons gained. What does that mean? Well, we know that if the electrons gained are 3, that the electrons lost have to be 3. Since we only have 1 iron, we know that that iron must be a +3. I know this is right if it works because every loss is a gain, every loss is a gain, every loss is a gain, and it's working out. So I know that this is iron 3 nitrate. It's really important that I'm able to do that and work backwards from the formula or even from the name and be able to find the ions. So that's really important. So next, least common multiple method. Remember, it works for every possible combination. So if I'm looking at the least common multiple method with that same problem, I have FeNO3, 3. I know I only have 1 Fe, so I put a 1 right there. I don't know how many electrons are lost yet. I know I have NO3, and I know that I have 3 of them, and I also know that it's a 1 minus charge. That means I know 3 electrons were gained. That means 3 electrons had to be lost, so the least common multiple is 3. What number divided by 1 is the charge? That would be a 3 plus. So again, we get the same answer. We get iron 3, sorry, my finger's not working, nitrate. Okay, pretty simple, not too bad, okay? Switcheroo method. Switcheroo method, remember it falls apart. If you don't understand where it falls apart, don't use it. So what we have is we have FeNO3, 3. Remember, that's not the 3 that we're taking. So the switcheroo method said that this 3 must have been the charge on the Fe, so that would be a 3 plus. And because there's 1 right there, that must have been the charge on the NO3, and that's right, it was a 1 minus. So we know that I have iron 3 nitrate. Okay, so reverse engineering is not bad. You just have to work through the problem and work it backwards. If you know the formula or if you know the name, if you know the name, you can determine the ions. If you know the formula, you can determine the ions. You just have to be able to work backwards to get there. All right, have a wonderful, wonderful evening.